Okay, so hello everyone, good evening. So we'll start plan 258. Yeah. Okay, so this is the agenda for today. So you will have group presentation, okay, and then we'll discuss about multi-criteria decision making, MCDM, okay, and inside we will go to the detail on normalization and ground reversal. Then we will also discuss about analytic hierarchy process or AHP. Okay. If we can finish, we can continue with Brown Gibson and prioritization. Otherwise, we can continue this next week. Okay, for the first part, so do you want to present first the group project? So who will present first? You can chat with me and to register who will chat, who will present first. Yes, but Blackness, go.
Okay, sir. Let me share the screen.
Can you already share?
Can you see the screen, sir?
Yes.
Good evening, everyone. I modified the title of my research to assessing the impact of tricycle regulation and road widening on degree of saturation, an AHP-based case study of MacArthur Highway in Binalonan, Pangasinan, Philippines. So the objectives of the study are the following. First, to assess the impact of different TMS. Second is to identify the most effective strategy using the AHP. And third is to provide data or information recommendations to the local government units or policymakers. And I also have three alternative scenarios or the strategies. First is to the total ban of tricycles, followed by the ban during peak hours only, and lastly, the road widening. And I have here also the hierarchy of my AHP for TMS. So the first level or the goal level is to identify the best strategy or the TMS to reduce the congestion on MacArthur Highway. The second level or the level includes the following five criterion. First is the traffic flow efficiency, followed by public transport and commuter impact, environmental impact, economic impact, and lastly, the feasibility of implementation. I also have here the bottom level of the hierarchy, which is the alternatives. First alternative is the total ban of tricycles. Second alternative is to ban during peak hours only. And the third alternative is the road widening. And uh, okay, I also use a AHP for my alternatives and criterion. By the way, AHP is a decision-making tool to choose alternatives based on multiple criteria. And I use a pairwise comparison matrix developed by Professor Saati. And the objective of pairwise is to derive ratio scales from pair comparisons. I applied my preferences at various levels of the hierarchy and combines these preferences to help make multi-criteria decisions. And I use the AHP scale or Professor Saati scale to show the intensity of importance of each criterion versus the other criterion. So from the scale of 1 to 9. And as you notice, there are also some values on the table that are reciprocal values, meaning this is to ensure the matrix is consistent and systematic. And the first step of the pairwise comparison is to put your values based from the scale of 1 to 9. So these are all my preferences. I have five criterion. And after you set the matrix, you will normalize the matrix. And you will, okay, I'll just show my Excel. So I have five criterion, the traffic flow efficiency until the feasibility of implementation. The next step of this pairwise comparison matrix is to normalize the matrix, where you need to sum up the column of each criterion. So this one up to here. And after that, you will get a value for each criterion. And after that, I calculated the weighted sum matrix. And the interpretation is traffic flow efficiency, the criteria number one, is the most important factor, about 46.4%, followed by public transport impact and the feasibility. And after that, to ensure that my values from 1 to 9 are consistent, I also implemented the calculation for the consistency ratio, or the CR, wherein you need to calculate for the CR value and the CI value. And I also use again the SAATIS table of random consistency index, or the RI, and I obtain a value of 0. Actually, it's a 0.002. So I just rounded off to 0. And if you get a value of 0, meaning the pairwise comparison is highly consistent and ideal. And I also applied AHP weights for each alternative under each criterion. So same process, I will give the values from 1 to 9 based from SAATIS scale on my alternatives. So I have three alternatives. And same, I need to normalize the matrix, then calculate for the AHP values. Then after that, I can get the five different values for my five criterions: the public transport impact, the environmental impact, the economic impact, feasibility of implementation. And I also have here some interpretation of the values. So let's take, for example, for this traffic flow efficiency. For my three alternatives, I get the values of 0.63, 0.26, and 0.11. And if you're going to sum up this column, it's equal to 1. So the interpretation is total ban of tricycle has the highest impact on improving the traffic flow, about 63%. And my next criterion is the public transport impact. So total ban of tricycle has the highest negative impact, which is 63%. And for my third criterion, the environmental impact, 0.64, 64%, the ban during peak hours has the most positive impact on the environment. For my fourth criterion, the economic impact, my calculated values are the following: 0.19, 0.72, and 0.08. So ban during peak hours is the most economically favorable compared to the other two alternatives. And for the feasibility of implementation, I calculated 72% is the least feasible, which is the ban during peak hours. And the most feasible option is the road widening, which is 63%. And after that, I obtained the final ranking using this formula. So the best alternative is the total ban of tricycle. The final HP score is about 0.151. And this is the results and discussion. The total ban of tricycles emerged as the most effective TMS, or the traffic management strategy, achieving the highest AHP score of 0.51. However, the feasibility of implementation score of 0.0525 suggests challenges in enforcement and potential resistance from stakeholders, particularly tricycle operators and commuters relying on them. Um, okay.
Any
I also put here, sir, my proposed decision-making model for my strategic planning. So since the tricycle operators and commuters will be mainly affected, so they should have the highest relative power
hmm,
for the policy making. And I was able to get the current traffic condition using a traffic count, because the latest information I get from DPWH is last 2013. So I made my own traffic count at the MacArthur Highway, and I found out that the current uh, congestion level now is about 0.77 and 0.79, 0.52, 0.47.
You did it alone?
I asked the help of my friends, sir, to do the traffic count
Oh,
in order to obtain the baseline traffic condition of the area.
hmm.
And currently, these are the DOS or the congestion level at the MacArthur Highway for the
Oh,
four lanes 1, 2, 3, and 4.
okay.
I only focus on the 1, 2, 3, and 4.
Okay. It's actually much beyond my expectation. Okay, so, but is there any input or feedback to breathness from others? I just feel probably you make a lot of good manipulation in the data. That your CR, your consistency ratio is super good.
Yes, sir. Actually, I manipulated to lower it down because the maximum allowed is 0.10 only.
Right.
The
So, but in reality, when you do real solving, it's super hard to get even 10%.
Yes, sir. You're correct, sir. Actually, the first value that I calculated is about zero point 0.5.
Oh,
Then I recalculated the CR again and I
right.
yield an answer of zero point 0.2. Then
Okay.
I further refined the pairwise comparison, and that's the time I obtained the value of 0.002.
Uh,
But it's a
So
trial and error approach.
I understand, but again, this a lot of manipulation that you do to
Yes.
the goal, no? But this is not the real world yet. Okay, that is okay for a good exercise, and I think you are quite understood with this method. Okay, and amazing actually.
Then, sir, I have a question regarding the forecasting of the future traffic condition because currently I only have the data for 2013 and 2025, and I want to project the traffic condition in the year 2030. Is it okay if I just use a exponential growth formula?
No, if you have only two data, basically you have only a linear model,
Okay. Okay,
right?
sir.
If you have more than two data, then you can do better than that, right?
Okay, sir.
If you have
Noted.
only 2 points, the only
Yes,
way
I
to
only have two
connect is only
points.
one line.
Yes.
Okay, so if you have 3 points on and so on, so you can get a better model. Okay, so if you have only 2 points, then
Yes.
there is no other way except a linear model.
Okay, sir. Noted.
But, amazing. Yeah. So maybe you can continue with the next part, which is the game theory and financial later. Huh?
Yes, sir, later on. Then I will also include the sensitivity analysis for
Oh, yeah.
the research, sir.
That's a small part on that.
Yeah.
Yes, super. Okay, so who else? Is there any feedback to Braveness? Okay, so Archie. Yeah.
I'm just amazed because he done it
Yeah,
alone.
he did it
Yeah, he done it
alone.
alone, sir.
Me too, I'm amazed. Okay. Okay, Lei.
Hi, sir. I would like to also congratulate Sir Resnet. I think he just
Okay,
published
cool.
a journal article also. And kudos to his work today.
Okay. You want to present next, Lei?
Sir Ray, do you want to present next?
So anyway, you need to present all today, right? So just the order. Who will present next? Oh, I think most of you already submitted, so all you need to do is just present it. Go ahead. Who will present next?
Sir,
Yes. Yeah.
I have a question for
Oh,
Sir
oh,
Press.
okay.
Sir, based on his discussion on his study,
Uh,
the option of total ban of tricycles,
okay.
am I correct? That is the most appropriate option?
Yeah, because he manipulated his data.
Yes, sir. My question is social acceptability also considered if
Um, good,
that
good,
will be the case?
good point, Kenneth.
Because of we all know that uh, our minor groups are relying on uh, tricycles as their source of income. But if we are proposing for the its total ban,
That's the reason why I put the tricycle operators and commuters as the most powerful sector in my decision-making model to at least uh,
integrate them
yeah,
their
correct. Their
perception.
concerns. Yeah.
So, what are the alternative for this operator if you ban them? I mean,
They can
and
use other corridors or roads except for the MacArthur Highway.
Okay. So there will be a new route assignment for
Yes,
the
a new route
tricycles.
assignment for the tricycle operators.
Okay. Thank you, sir.
Yeah.
I think good clarification. So it's not the total ban all, but only in the main highway, right?
Yes, sir. Correct, sir.
Thank you, Sir Bress.
Thank you.
Thank you. Yeah. But next, Kenneth, you want to present?
Sir, our group has a short
It's okay.
progress report.
No problem. No problem. Yes.
Okay, sir. But we can present now, sir.
Yeah. Okay. So,
So I would like to request Sir Carlo to share our presentation.
mm, okay.
Sir, maybe I can be the one who will share.
Okay. I think you are already co-host.
Okay, sir. Thank you. Um, okay, so good afternoon, sir. Good afternoon, classmates. So here is the progress report for our group 8. So our study is about the transportation service preferences of the college students in Metro Manila. So we focus on the student population since they are the majority uh, group that often use public transportation, especially in Metro Manila. So for our study, we identify the study area. So they are the students from the National University in Manila. So the university is located in the heart of Sampaloc area, a busy area of Metro Manila. And for our sample population, we opted to uh, choose third-year college students under the BS Architecture program since Mr. Carlo has a direct uh, connection with them. They are his students. So we will not have difficulties in collecting data for our research topic. And for the transportation preferences, we will focus on public transport services. This will be based on the origin destination survey. So the origin will be their respective homes, and the desired destination will be the university. So this will be our scenario. So we would like to determine what will be the deciding factors on the students' transportation preference. So based on the cost, the travel time, the satisfaction for convenience and comfortability, okay, and efficiency. So based on these factors, we identified these attributes. So first is the gender, based on gender, the transport cost, and for the travel time, we identified three attributes: the reduced travel time, the standard travel time, and the extended travel time. So under the satisfaction level, we identified four attributes: the uh, efficient and comfortable transport service or transportation activity. We also have efficient but uncomfortable, inefficient yet comfortable, and inefficient and uncomfortable. So these are the four satisfaction levels that we would like to assess from our respondents. And based on the initial observation, there are four possible types of transport service modes from the origin and destination. So this includes jeepney, buses, trains, particularly the school in consideration is relatively close to one of the stations of the LRT Line 2, and other options for TNVS or the Transport Network Vehicle Service like Grab, Angkas, the motorcycle taxi. So these are the pre-identified options for transport services. So by integrating these attributes in our survey questionnaire, which we are uh, designing at the moment, sir. So our group will enable to determine the factors influencing the transportation preference of the student respondents. So after we conduct the data gathering and uh, acquire the required sample size, data will be analyzed using the Ideal Flow Network Labs tool, which was presented before by Sir Kardi. So we will utilize that tool in order for us to generate the corresponding flow network for a specific transportation service. So for each transportation service, we would like to determine how many of the respondents are utilizing each transport service. And aside from that, we can also check if there are students that are using multimodal transport service. So we can also determine if there are combinations of these transportation modes based on their answers from our survey. So these will be some of our variables if we would if we will run it in the IFN labs tool. So these will be some of the combinations. And after running this application, we can identify this flow network. Okay. So based on this assumed data, the capacity for each flow will be identified and be used to analyze the ideal flow network. So we will determine the flow network for each transport service mode. So that's our progress report, sir. So currently we are designing the survey questionnaire.
Okay. Wait. So can I give you suggestion?
Yes, sir.
So yes, you want to use the IFN for table classification. That's what you want to do, right?
Yes, sir.
Okay. So let me give you in the chart for everyone. So this is the link for IFN for table classification, but there is also similar things there. You can also use what is called logic model. This is the traditional way to do transportation. So
Okay, sir.
then you can compare. Actually, if you have the tools, okay, in Python, for example, there are many model of data science that you can use for the same purpose. You know? For example, this decision analysis, naive and many others. Yeah. So each of this technique will have, of course, strength and weakness. Okay.
Yes, sir.
Okay. Or for example, SPM, for example, these are one of the technique that you can also use. Okay. But
Yes, sir.
at least these two, the one that I gave you, the IFN and the logic model, these are the practically traditional method you're supposed to compare.
Yes, sir. Okay, sir. We will include the comparative analysis
Yes.
of the two models, the
Right.
IFN model and the logic model.
Right. So the IFN also have a possibility to generate the input out of your output, right? So for example, who is actually using bus or who is actually using a car and so on. So you can
Yes,
keep
sir.
iterating there to get the actual pattern that you can start to understand what is the actual pattern of your input to get that output.
Noted, sir.
Any other comment or feedback to this group? Other group, no? Okay, so then thank you. So
Thank you, sir.
let's go to the next group. Play.
Yes, sir. Sir, can we show our presentation, please? Um, for a while, sir, survey is for preparing our slides. Alright, thank you. So, good evening, classmates. Good evening, Dr. Kardi. So, we're going to present the progress report for our reel number 1, the whale shark interaction system in Donsol, Philippines. So, this topic was as advice, as your advice with Sir Ray's work previously for the IFN. We have employed this as our first reel. So, on the next slide, we're showing our progress report. So we have set our topic, we have changed our topic to the whale shark interaction systems in the Philippines, and we're going to use ideal flow network for power dynamics. And our approach will be comparative analysis of the three models of the typical Donsol season, the Donsol off-peak season, and the Oslo. For the data collection, we're using realistic assumptions based on Surrey's personal experiences and anecdotes, and also online features and articles. Also, for the footage, Surrey will be going to their province to catch catch or record some personal footage, and also we're gonna use stock footage as well. For the status, we're currently doing the script writing since the ideal flow Excel file that or the ideal flow assignment that Surrey did a while ago will be
Last
our
week.
presentation. So I'll be turning the table to Surrey for the presentation of the PowerPoint Excel for a quick recap.
Hi everyone. So for a quick recap um of the network that I formulated for this topic. It involves the five key players. We have tour boat operators, LGU, and the tourism office, the policy making bodies, the tourists, the whale sharks, and the boat landing interaction officers, or the BIOs. So for the first reel, we envision it to be a comparative analysis of as mentioned by Lee earlier, of three scenarios: the Donsol off peak, and then the Oslo Cebu. Upon further research as well, we found that there are also activities being held in Bohol, in different towns in Bohol. And government there has enacted some measures or some new policies on a total ban of the activity. So that we could factor in that those news into the reel. So before we go further with this topic, we would actually want to clarify, sir, whether the three reels that are required from us would be required to be related. Could be an application of a different theory in this topic, in the same topic, or different topics overall. So we want to clarify that.
If possible, you unite everything, but different point of view.
Okay.
But
So
I would like to remind that this is a group work rather than just one person. So I hope the others can also support. I understand you presented this last week, but when it become the topic of the group, then the other group supposed to give a lot of support rather than just one person.
okay, sir.
Okay.
Yep, that's it for our progress report. We're already writing the script for the first reel, since I think the one for IFN Power Dynamics is already solid in terms of
Right. Yeah. Your presentation last week was amazing. So
okay, sir. Thank you.
thank you. Good. Is there any comment feedback to Ray and Lei? Okay. So if not, next is Arfin. Chat me for the queuing, okay, for the other groups.
Okay. Is my screen showing now, sir?
Yes.
Okay. So for the progress report of our group, again, we're the AAA group because our first names are starting with 8. Okay, so for this report, we divided it into 7 parts. So again, the updated proposal of the topic, and then the description of the base scenario. Because from the first topic, which is mostly focusing on vehicular traffic, right now we're trying to model pedestrian flow instead of vehicle. So, and then the alternative scenario, the data requirements and structural dynamics. This one is directly hailing from the power dynamic topic that we had, and then conceptual framework and the ways forward. So we're not yet on the writing the reels yet. Okay, new topic. The new topic title would be modeling pedestrian flow. Again, in junction Santa Rosa, Tagaytay. So connecting Laguna to Cavite area, which are both high influx cities in the Calabarzon region or the southern Luzon. So the objective is to assess pedestrian traffic and evaluate alternatives, ensuring efficient mobility and improve road safety. So particularly pedestrian. The study areas mentioned is the intersection of the Santa Rosa Tagaytay Road and Rizal Boulevard with Manila South Road, which is the north-south backbone in the Philippines, following the AH-26. Okay, and for the prevailing land uses, we have residential, commercial, and industrial. But near the intersection proper, it's mostly commercial. And the actual use would be retail-based. So as to the base scenario, we marked here the existing footbridge and existing pedestrian lane. Take note that the southern leg, this one, of Manila South Road has no pedestrian facilities. So pedestrians cross it without actual crosswalks or footbridges. But on the north side, they establish a footbridge, but it is underutilized, probably because it is 2 stories high. So people are hesitant to use it. So they instead go or flow as a crosswalk on that leg, which is the north leg. So they come and go, assuming it's a crosswalk, while there is an existing footbridge. So it's an undesirable pedestrian behavior because it is actually jaywalking. And their lives are at risk because it's Manila North Road, which is high traffic density or high traffic flow. So, and then there's also absence of pedestrian signal, traffic signal. So there's no time on the facing diagram of the existing traffic signals for pedestrian. So pedestrians are given the decision when to cross. Okay, so we want to improve this scenario and try to model the pedestrian behavior and locate which are the points of concentration of this pedestrian movement. So if they are, for example, on the minor leg, they're following the crosswalks, or for the major legs, where are they jaywalking? So to be able to model that kind of behavior. So for the alternative scenarios, Jello would be the one discussing this. Jello?
Okay, thank you. Yes, thank you, Sir Vin. Hello, everyone. For our alternative scenarios, given our base scenarios, we are aiming to model the pedestrian flow on these 3 alternative scenarios. The first one being the prohibition of undesirable pedestrian behavior through strict enforcement of existing policies. Later on the structural relationships, I believe so, to be presented by Sir Archie. We will see that the policies plays a crucial part in the overall pedestrian flow, and that we will see by modeling this if there will be an improvement in the pedestrian flow with strict enforcement in the policies. Next is the increased utilization of pedestrian crosswalks and footbridge by installing additional physical barriers. Currently, in the intersection, there are barriers. However, it is not screwed. It is not how do you call it? Screwed down. It may be moved. Pedestrians are able to slip through, causing let's say not congestion, but causing safety concerns for both pedestrians and the motorists with the vehicles in the area. And lastly is the provision of facilities intended for pedestrian use and the continuous monitoring and guidance of pedestrians by law enforcement and social media. Social media or media in general also plays a part here, which will be shown later. And then with the two alternatives, the second alternative scenarios, by the increasing the utilization of pedestrian crosswalks or by presenting additional physical barriers, we aim to maybe have pedestrians utilize existing facilities, more facilities, the introduction of more facilities. And by existing, we mean the footbridge, the two-story high footbridge, on how it may improve flow if it will be utilized. So next slide, please. For the data requirements, so we will be looking into the inventory and the dimensions of pedestrian facilities, the trajectory of pedestrian movement or the layout path of pedestrians, the foot traffic on all pedestrian crossings during peak hours, and this is important to note that our data will be anchored on the number of pedestrians during peak hours, the actual pedestrian behavior, and the crash data involving pedestrians. Now, these data requirements will be the means of gathering these data will be on Sir Archie because he has he knows the area and he also knows people who would be able to provide us. And I would like to turn over this to Sir Archie if he has anything more to say about data requirements, and he will also be the next one to present.
Yeah, thank
Sir
you,
Archie.
Sir Jello. Salamat malam, Doc Kardi. Good evening, classmates. Okay, next slide, please. Okay, as discussed the previous slides, we have this the structural dynamics, or AKA our IFN structure. So servicing the stakeholders here, and agents, and so we consider the policies, the enforcers, the media, the physical facilities or the infrastructure, establishments near the area, which contribute also to the change in behavior of the pedestrian. So basically, this is our structure. So we decided to make this one so we can identify who's the more powerful and who influences the pedestrians. Okay, so next slide, please. Okay, for the conceptual framework of our topic, our inputs is the pedestrian count. Basically, sir, I did 2 weeks ago already by myself. I already counted. Actually, it's in weekend, the peak hour, 6 p.m. to 7 p.m., the pedestrian count, and also took some pictures how the pedestrian behaves, where they go, how they use the existing pedestrian lanes, and also the existing footbridge, which is underutilized. So there, I have some records. The next is the road and intersection geometry. We will get the size, the physical characteristics of the road. No, not also the road, but also the footbridges, how far is from the intersection, the pedestrian lanes, what is the width, and how far is it in the section, and other facilities that might influence the behavior of pedestrian crossing those roads mentioned. And the land uses, as I mentioned, this area is primarily commercial area with establishments, various establishments. crash data and related. I will get this one personally from the police station near if they can provide some incidents or accidents involving pedestrians in that area, and the statistics as well. We will do the statistics. For the process, data collection, as I mentioned, analysis of the base scenario, then mentioned the alternative scenario and the development of it, and then we will do the comparative analysis from these alternative scenarios to the base scenario. And the outputs, as you can see, we will have how we can improve the behavior of pedestrian using those existing facilities or the the suggested facilities to enhance the safety of the pedestrians. And also strategic implementation, if possible, there will be construction or additional facilities. And also next is the monitoring and evaluation system. Next slide, please. Okay, moving forward, for the data gathering, I have to ensure a comprehensive assessment of pedestrian flow at the intersection. A structured data collection approach will be collected using manual counts. So I will be doing my manual counts with my relative, my cousin, to do. Yes, I will just. We will just do the counting of pedestrians.
Your groupmate should,
sorry, sir.
Your groupmates should too.
No, it's okay, sir. No worries. They will do the computation. It's just, so the pedestrian count, we will do that, and GIS mapping, we can do that, and secondary data. If there's, like I said, the secondary data we can get from the police station and LGU. We will do it by next week. And number two, the modeling optimization, following after the getting of the data collection, a pedestrian flow model will be developed and to stimulate the base scenario and optimize the identified alternative scenarios. So with that presentation, thank you very much. Questions?
Can you go back to the structure, network structure, or
the dynamics? Yes.
Yes, okay. So I think policy must be the whole structure itself, well, not one node. So policy is not one node, but a system. That means the whole policy. So that means you will have different policies. And then I think you have missed pedestrian to establishment. Okay. So what's the point in here? The point is this. The point of view, you always think pedestrian is a burden. That's why you want them to behave. Okay? So you think you put them as jaywalk, something, you need to behave, but you never provide facility for the pedestrian. Okay? Because you think pedestrian is a burden. But try to think different way. Okay? Pedestrian means demand for establishment. That means profit. Okay? That means, that's why I asked pedestrian to establishment. That is the most important part there. Okay? That means profit is not a burden. In fact, establishment need pedestrian to make a profit. Okay? So in that case, you can start to create, instead of enforcer, you start to create alternative, which is not there in the alternative. What is the alternative that actually would make pedestrian come to this place more rather than less? Okay, that means, example, in other cities, including the city that I'm living in now, okay, they create underground pedestrian mall in that intersection. Okay. So with museum, with a small connected mall inside, underground. So now the policy, meaning that the government need to allow this to happen, okay, so that the establishment will earn a profit out of this by building this. So it solves two problems at the same time: the safety of the pedestrian, and then the establishment also improve the economy in that part, right? But when you think different way, like, oh, I need to make the pedestrian as a burden that you need to regulate and so on, then there is no innovation in here. You practically just make them less rather than make them more. Isn't that reverse thinking that you need to do? Do you get the idea?
Yes, Doc. Yes, Doc.
We need to
We got your point,
attract
sir.
more pedestrian in that place because it's already established there, right?
All right, sir.
Okay.
Yeah, we
It's
got your
not,
point, sir.
it's not the other
Yes,
way
sir.
around.
Yeah, sir. We will maybe I think we will go again to this to the blackboard and change this one. Yeah, but that was we are thinking last time, sir. If we provide just infrastructure to use, maybe there's something
So the
we
way
need
to think is that's the most important. The way to think pedestrian is actually demand for business. It's a profit, not cost. It's totally reverse way of thinking. Okay. You want more pedestrian, not less. You want to provide convenience and satisfaction for these people to come more in this place. That is the essence. Okay. Otherwise, this problem, recurring problem, because way of thinking is reverse. Okay. You hate pedestrian. I don't understand why. I mean, this government does not provide any facility for pedestrian, right? With this totally reverse thinking. Okay. You need pedestrian because everyone is pedestrian at some point of time, isn't it? Whether you use car or you use public transport, you are pedestrian. From the parking lot to the place, you still need to walk. So I hope start to think a different way. Okay. When we talk
Yes,
about
sir.
pedestrian.
Yes, sir. This is duly noted po, sir. And also, for our third alternative scenario, if I'm not mistaken, we have also included the inclusion or an installation of additional facilities for
Yes, yes.
pedestrian use.
So that will include, for example, underground walkway with the
Yes.
museum, with the small mall. Okay. Air condition inside so that people will walk there.
There are some models already in some cities in the Philippines.
Exactly.
Yeah.
Right?
We can take inspiration on those best models, especially on the
Yes.
marketing side.
Right. Okay. I mean, the way of thinking is totally reversed, right?
Yes, sir. I appreciate
Making pedestrian as a burden.
the input, sir.
Yes.
There should be a shift in the thinking and rethink
Okay.
this whole power dynamics.
Yes.
Okay. So I hope.
Thank you, sir.
Okay, no problem. Put two scenario at this point. That scenario is okay, and then you add additional, and then network structure, and then you can
So
start.
instead of controlling their movement, it should be
Eastern.
increase pedestrian density.
The pedestrian.
Yes, increase
Yes.
pedestrian density. That's
Increase pedestrian.
empower them.
Okay, sir.
All right, sir. Thank you very much, sir. Thank
Okay.
you.
Thank you, sir.
Thank you, sir. Thank you.
Yes. Okay.
Okay.
Is there any other feedback to this group? Yeah, Kenneth.
Sir, your suggestion about shifting into a more people-centered alternative is very much appreciated. Even I'm from the other group,
Yeah.
so it's a good suggestion, sir.
Yes. So remember, you are urban planning, transport planner. So who you plan to? Who is the target? You don't plan for yourself. You don't plan for government. You plan for the people. Don't forget that. Okay. That's the most essential part, right? So I hope don't miss the target. Okay, so Karina and the groups.
Hi, sir. I can't seem to share my presentation.
Let me. Oh, you are host already. You can share. Go ahead.
Hi, Omar. Can you share the presentation?
Okay. Is there any technical difficulty to
Yeah.
share?
There.
Okay, Omar. There.
Okay. So our topic is evaluating last mile accessibility and walkability. In relation to the previous discussion of regarding the pedestrians, next slide, please. So our agenda is introduction to the study, case study selection, network structure for strategies and stakeholders, MCDM and stakeholder consultation, optimization model formulation, solution analysis, and calibration. Next slide, please. So the challenges of a commuter are poor pedestrian infrastructure, unsafe road conditions, and disconnected pathways, making walking to transit hubs inconvenient or hazardous. This in turn makes walking to transit hubs uh, um, uh,
Yeah.
their safety are compromised, and then the accessibility, and then there are issues with the infrastructure in terms of going to the destination. So this study aims to evaluate pedestrian connectivity, safety, and accessibility, identifying gaps and proposing data-driven improvements. So for this one, our objectives is assessing accessibility to evaluate the current accessibility for identifying barriers and challenges. And our study area is in Cubao. And then enhancing walkability. It aims to optimize walkability in the first last mile to improve the overall commuting experience for pedestrians. And then urban mobility solutions, in which findings may provide insights and solutions applicable to enhance urban mobility. So for our case study selection, next slide, please. So Cubao faces significant urban accessibility challenges, particularly in pedestrian mobility and first last mile connectivity. And the city struggles to efficiently connect residents to transportation hubs. Our research aims to evaluate existing infrastructure to identify critical gaps and propose optimization strategies to enhance pedestrian accessibility and urban connectivity in the area. Next slide, please. So for our network, there is the LGU, which is responsible for policymaking and funding. There are urban planners, which focuses on infrastructure design and assessment, and then the commuters and residents, which are the end users. So for the multi-criteria, which is the basis of decision making. So this is consensus-based decision making, which is the process that emphasizes collaboration among stakeholders. And then there are stakeholder consultations, which is essential to gather insights and understand the needs of the commuter within the urban environment. And then there is GIS data analysis. And the GIS data analysis to help in understanding the movements and patterns which guides effective urban planning decisions. And so for our optimization model formulation, we chose the shortest path model, which evaluates efficient pedestrian routes. And then the facility location model, which optimizes the placement of the first and last mile infrastructure, such as covered walkway and accessible design, enhancing urban mobility. And then there is agent-based simulation, which predicts pedestrian movement and congestion patterns. And this provides insights for urban planning and management. So for our solution analysis, there is a transport office to provide data on pedestrian flow and transport access, to understand urban mobility patterns. And then there is MMDA open data to gain insight into traffic congestion and pedestrian accidents. This will help in identifying safety and efficiency issues, and Google Maps and GIS data for walking distances and land use, and then comparative benchmarks, which uses data from walkable cities in the metro and outside the country, like Singapore and Tokyo, to provide valuable insights for urban development. And then lastly, accessibility is not just for people, it's not just we're referring to accessibility not just for people with disabilities. This concept, known as a curb cut effect, refers to how features designed for specific groups can help a broader audience. So that's it for our presentation.
Is there any specific scenario alternative that you will check? I think you have too much emphasis on the data gathering. Okay, but I want to see what is the actual scenario and strategies, for example, that you can use to analyze this, so that I can see the goal can be achieved or not.
Sir, for this one, we will using the different criteria that we have, such as accessibility, walkability, and for accessibility, walkability, and mobility solutions. So we will evaluate pedestrian connectivity, safety, and accessibility, and we will identify the gaps in proposing data-driven improvement. So what we will do is we will evaluate this criteria, such as pedestrian connectivity, safety, and accessibility, and then we will be assigning weights to this one, and then based on the criteria, what we will do is actually optimization. So from this criteria, we will assign values and
Okay, so if you want to create an optimization, you need to have an objective. Okay,
okay, sir.
you need to have alternative solution, which is feasible or not, and then among the feasible solution, you need to find which one is actually the most optimum. Okay, those are the steps, right? But at this point, you mentioned the criteria, which probably almost similar: accessibility, walkability, mobility. So those only three criteria that you mentioned, but I did not see the alternative, or at least what is the criteria to make it feasible or not feasible. Right. So is it possible to improve on that part first?
We will do, sir. We will improve on that part.
Yes. So I did not see alternative yet. So what is the purpose of evaluating accessibility, walkability, if you cannot even give any solution? Say, without all of this, okay, you already know that this is not enough, for example. And after that, so what?
For this one, sir, we will be determining the shortest path, and then which among the shortest path is the since the first and last mile provides the experience for the pedestrian in going from their first destination, from their homes to the first destination, to the first stop, which is a transit hub or a transportation mode. We will be evaluating which gives them the best experience in terms of if the path is like I said, is it walkable, is it accessible? So from there, we will, and also in determining the best route to go there.
So there's an assumption that you mentioned here, hidden assumption, that the trip purpose is actually to go to commute. Okay?
Yes, sir.
That's why you are talking about shortest path. But in Cubao area, okay, the trip purpose is not only commuter, right? So I agree with you about best experience. But shopping trip, for example, are not shortest path. So you probably need to divide this into a different purpose, right? For the pedestrian.
We will do, sir.
Right. And I'm not sure if this is just a simple survey or you actually, because there are a lot of technology already doing what is called tracking rather than counting. So we can track the pedestrian, where are they going and so on. There are a lot of papers in the past decades about this. So I'm just worried that this is just like backward 30 years ago rather than using the latest technology. So please reconsider about your approach. Okay. My point is, what is the innovative part in here that you can use the tools rather than just doing simple survey and collecting data? And what is the purpose of all of this study? Okay, if you did not provide any solution. So I hope you can start to create an alternative solution. Okay, at least what is the criteria to make it feasible or not feasible? Okay, and then we talk about optimization.
Okay, sir.
Okay. Okay, so please improve in the next presentation next month. Okay, so who will present next? Yes, Paul, Sam.
Our group, sir.
So,
Pearl, wait, sir.
Wait.
So while Pearl is sharing her screen, so I will just introduce ourselves. So we are the PPP group, and I'm with Miss Pearl Reyes and Sir Patrick Santos. So we will be presenting the existing operations and maintenance or O&M system of the EDSA bus carousel or EDSA busway. So this one, the one that we made, aims to analyze the key stakeholders involved, their influence on one another, and the overall network structure that governs the system. So also the EDSA bus carousel is implemented along the EDSA, designed to improve the mobility, reduce congestion, and provide a more efficient transport options for commuters. So its operation is governed by various agencies, including the Department of Transportation, the Land Transportation Franchising and Regulatory Board or the LTFRB, the Metropolitan Manila Development Authority or the MMDA, and the private bus operators, and among others. So each of these entities plays a crucial role in ensuring the smooth functioning of the system. So to better understand the interaction within the system, we have developed a capacity matrix that quantifies the level of influence each stakeholder has on the others. So this matrix helps us identify which agencies have the most control, how responsibilities are distributed, and where improvements can be made. So We will also explain the methodology used to construct the capacity matrix, provide insights into the power dynamics within the system, and discuss how possible adjustments in the network, or we're currently exploring how possible adjustments in the network structure or influence strength can lead optimized and more efficient operation of the EDSA carousel. Pearl, is your screen where's your
Let me share my screen. Is it visible now?
Yes, please.
Yeah, so hi, good evening, everyone. I'll be presenting uh this a little bit crazy network that we have going on regarding the operations and maintenance. So please bear with us. We were not able to fully fix the whole network properly, since there are a lot of interactions and key actors here. So um maybe we can start with the core agency, which is the DOTR. So the DOTR as the center influence or has links to multiple entities. So we have its attached agencies, the LTFRB, the LTO, the MRT3. Uh, these four entities work together mainly in the transportation sector. So you may be wondering why MRT3 is here. So there are certain areas or in the busway infrastructure that is shared, or there is shared infrastructure between two modes. So they are also involved in this network. So from there, uh, the current situation, the current institutional arrangement also involves other agencies outside of the transport sector. So we have the infrastructure sector with the DPWH, or Department of Public Works and Highways. Sorry, let me pull out my pointer. Uh, oh, sorry, I cannot use a pointer. Oh. Yeah. Okay, sorry, I cannot use the pointer, but yeah, I hope everyone can follow. But yeah, the DPWH assists as the infrastructure arm of the government, assists the DOTR in terms of infrastructure matters, maintenance of the road, the lanes, and the construction of the bus stops. We also have two other agencies mainly concerning enforcement and traffic management. Actually, three to be exact. LTO, Land Transportation Office, has an enforcement arm. The Philippine National Police Highway Patrol Group also has an enforcement arm and an enforcement role. The MMDA also has an enforcement role. And actually, even the LTFRB also has an enforcement role on the road. So, if we see there are four agencies fighting, or at least having the same or similar mandate of enforcement on the road and traffic operations. If we look down towards the right portion, if we can see the LTFRB. So since the LTFRB is basically like what we call the transport authority in other countries, they're acting like a transport authority of the Philippines. So they have a lot of linkages. First, we have they are the main regulator of public transport services. So they are a terminal regulator. They also regulate fleet management system providers. They also regulate automatic fare collection system providers. They are the grantor of franchises. So they regulate the bus operator consortia, which is made up of two consortia, the Mega Manila Consortium and the ES Transport Consortium, which operates the EDSA busway. So aside from that, the LTFRB is also a regulator of conductors or bus conductors. So there are links between such. And I forgot to mention bus drivers are also linked with the LTO, since the LTO is the regulator of drivers on that side. And both LTO and LTFRB are the two main land transport regulators in the country. Aside from that, we have the commuters, of course. This is basically our the common goal, or the common benefactor of this whole system, of this whole operations and maintenance, is the commuter. So the commuters are linked through drivers and conductors. Of course, the drivers and the conductors, they are the two main stakeholders that are facing commuters directly when they ride on the bus. So commuters are also empowered to give feedback regarding the operations and maintenance of the busway to the Department of Transportation, to the MMDA, sometimes to the LTFRB also. So there are multiple agencies where commuters could provide feedback. Aside from that, the enabling providers, like the fleet management service providers, the automatic fare collection system providers, the Parañaque Integrated Terminal Exchange. These are the providers, terminal providers, system providers, which are contracted, or at least have links between them and the bus operator consortia. So they're engaged by them to help in the operations of the busway. So at the moment, the network sort of looks really intertwined. So we are trying our best to sort of propose a structure where the O&M of the EDSA busway is privatized, so through a public-private partnership agreements. So there are the government's move is to privatize the ownership, the O&M of the busway, and we're trying to see how we can optimize this whole network in such a way that it's much simpler, and the interconnections and the conflicting mandates, the operations, the functions are not overlapping. So if we can move to the right, Pearl, we can show an initial proposed network considering the privatization of the EDSA busway through a private concessionaire. But this is actually not yet complete, because not all nodes have been considered yet, and we're also looking at how we can better sort of link together the various actors, and so that the system is much simpler, lesser overlap. So maybe we can move to the analyzing the existing network. Pearl, if you can present the Excel file. So we did a ideal flow network and analyzing the relative power, considering the existing network first. So yeah.
Okay. So I have
Sorry. Pearl. Sorry, sir. Pearl will present the Excel file.
Hello.
I don't think you can calculate using IFN. This is so big like this. Right?
Yeah. Actually, we're experiencing some problems already, considering the right, Pearl. I think there are issues with trying to get the flow, the IFN.
Yeah, it will all zero, right?
Well, based here, sir, so far we were able to get some values from the capacity matrix. So we initially assumed the links to be just 1 or 0, no weights yet on the relationship between various actors. And actually we will recheck again our capacity matrix because the network is already like spaghetti, so we might have missed some links between the nodes. But so far, based on the this is the IFN from the existing O&M network of the busway. If we scroll down to the computation of the relative power there. Based here, the IFN came out. We used DOTR as the base, so considering that the DOTR is the main transport agency responsible for the public transport operations of the busway. So looking at it, the relative powers of each actors are as follows. The minimums are and it can be seen on the network actually, the fleet management service providers, the Metro Rail Transit 3, and the Department of Public Works and Highways have the least power in terms of the overall influence in the busway, since the MRT3 only coordinates directly with the DOTR central office on coordinating shared infra, DPWH, purely on roadworks, not so much on the actual operation of the public transport service. The providers, both the fleet management service providers and the automatic fare collection system providers, they're more just have a service contract between the consortia and the providers, so they have relatively low power. Of course, we expected the OTR, LTFRB to have the one of the highest powers here, considering they are the regulators. But if we notice, commuters here are I think 0.6, if I'm not mistaken. Yeah, 6 out of 10. So
Okay. So
yeah.
Okay.
Yes, sir. So yeah.
My point is a few feedback for you. Okay. Number one, can you just focus on the essential structure? That means you need to combine several agents here which have similar functionality into a group of stakeholders. Maybe not too many nodes, yeah. So maximum probably 7. So you can create a component with a super node rather than just a node. Okay. For example, your bus driver, your operator, and conductor a while ago, it seems like you did not make the node between operator and driver, but it's supposed to have, right? So in that case, you can create a component. So in that case, the 3 of them can be combined into 1. So in this case, become a smaller number of nodes. Number 2, irrelevant stakeholders can be removed. No? So you only, I don't know, you said many agencies are actually overlapping and similar mandate. So in that case, can they be combined into a larger category? Yeah. So,
Yeah. Understood, sir. I think the providers, bus driver, conductors, and the providers, maybe they could form
right.
all the providers could form one super node, the operator and bus driver and conductor. But the agencies that's actually what we want to highlight, because this is a real life experience.
I understand. So
yeah.
maybe you can create a hierarchical structure among these agencies so that probably you can combine them. I don't know. So, okay, so the goal of this project or the course is actually for you to create feasible and optimum policies, change. Okay, policies mean change. The strategy. Okay, based on this analysis, what are the policy? What kind of change that you want to do? Okay, so this is
Yes, sir.
existing condition. That's okay. But what are the alternatives? So the same as earlier group, no? Karina, Omar, and Tumo. You did not mention about alternative policy.
Yes, sir. Actually, the privatization was the policy that we're
Okay.
looking as an alternative scenario, but
So
we
what
didn't
are you
have
doing
enough
from
time
there?
to we didn't have enough time to map the whole network because we spent I think bulk of the time was trying to also form the network of the existing, considering
Right,
all of the many actors. So
right.
we will answer. We will catch up on the alternative scenario, which is the privatization scenario of
Okay.
the O&M of the busway. And
So
yeah,
in that case, between the base scenario and the alternative scenario, there should be a lot of overlapping, right? Meaning that the change should not be totally changed, totally different network, right? Should
correct,
be
sir. Correct, sir.
network, and then you highlight which part of things that change, isn't it?
Yes, sir. Correct.
So your privatization a while ago seems like totally different network. So I just worry this is not change. This is totally different now.
Yes, sir. Yeah, we will improve on the alternative, the network of the alternative scenarios, sir. Actually, that's not yet
Okay.
complete yet, sir. Yeah.
So I hope next month we can see a better improvement. Thank you for yes. Is there any comment or improvement for this group, Omar?
Thank you, sir. Actually, sir, I'd wait first if there's comments because I just want to clarify something on our topic. Yes.
What?
Yes. So, sir, actually, the policy change that we want to do is for the government to provide of course, possibly in cooperation with the private sector to provide a better walkable city for pedestrians. I think we have to establish that. So currently, now the last mile, people mostly in the Philippines, they take taxis, TNVS, motorcycles, even jeepneys sometimes for a distance that would be otherwise walkable if 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 a conducive walkway or pathway will be provided by the government or in cooperation with the private sector.
I agree with you. So the only problem is only your presentation did not show what you want to say.
Yes, sir. Yeah. Actually, we're just not clear about that. But for our next presentation, we'll make sure that we would include the baseline and our target goal.
Right. So the network structure is supposed to say the one that you just said.
Yes, sir. Yeah. That's our actually our goal here. Yeah. Thank you.
Thank you. Thank you. Jane Marie gave some comment here to the Sam and Pearl and Patrick group, I think. Can you answer that?
Yes, sir.
Actually, that's for the previous groups.
The previous group. Okay.
Yeah, I was simply asking, because they want the EDSA busway to be efficient. So, and they have so many stakeholders involved, specifically the government. So I think if they consider each of the variable like travel time, passenger capacity, service reliability, it can be attributed to each of the government offices and make the study more focused on the efficiency of the EDSA bus.
Right.
It's just a thought, sir.
I think this is a good feedback. So that's what I mentioned a while ago. If is there any, based on your goal and your problems, so irrelevant stakeholder can be removed, right? So if the stakeholders are not really related to your goal, even though they are there, but that is out of the scope of the study, so you can remove from the, or you can combine them as one group. Any comment? Sam, Mark?
Yes, sir. Actually, we will take the suggestion to combine some of the common actors, but looking at the how it is currently, or based on the network that we have, most I think all of the actors that we placed are quite important. I mean, that's what we're
Okay.
trying to
Let,
show.
let's do it this way. This is simulation only. Okay. If you have a chance to become the president of the country, simulation only. Okay. What change you will change in that structure that currently have in order to make it more efficient?
Yeah, yes, sir. One suggestion I've been wanting to push is to combine the transport regulators. So the LTO, the Land Transportation Office, and the regulatory board should be one into a transport authority. Maybe even joined together with the DOTR as the transport agency, as the mother agency. So instead of three agencies, it becomes one.
Okay.
That's one
Can you
suggestion.
simulate that? Anyway,
I think
this is the
yeah.
study, right? Within the class. So,
We will try to stimulate it, sir.
right. I think if dare to see different way rather than what is currently have. Okay. Anyway, just study, no problem, right? Can you start to think different way? That if I combine all of this, what will happen? If I do,
Yes, sir.
you just said a while ago, what will happen?
Yeah.
Okay.
Yes,
Will
sir.
it actually better or not? Then you can calculate. You have the tools to compute, isn't it?
Yes,
So
sir.
then you start to see, okay, if this is actually better, I don't know also better or not, right? So after you compute, then you can say, okay, this is actually not better. Okay, the current one is better. That's okay. Or maybe the one that you've suggested actually better. So then you can start to make a noise. Yeah. Right. So anyway, that's the purpose of study, isn't it? So dare to challenge the actual current situation. Okay. I understand you will say, I don't have the power. Well, imagine that you have power to change. What you can change. Okay. Having power does not mean that you can change if you don't even have idea to change. But now that you have idea to change, then you can make noise, then you can have power eventually. So it's the other way around. The way of thinking is not even the power first, but you assume the power first. You need to have faith here. Okay. Okay, good. So who's next? Who did not present yet? Franz, I did not see you yet. Anyone?
Hello, sir.
Yeah, go.
Oh, you requested me to unmute.
Hmm?
You requested me to unmute.
Yeah, so did you present already your?
Not yet. Okay, I will share my screen. What's Can you share? Can you see my
Yeah.
screen?
Yep.
Okay. So it's my progress update, right? So this is my progress update. Um, there. So for my research, so I've been focusing on data gathering first because it's rather technical. So I'm gathering the class schedules from CRS. So because my topic is based on class schedules in the UT system. So the database for the schedules is on the CRS. So this is the sample that you can see from accessing CRS, and you can see the raw data when you right-click inspect element. So you can retrieve the class schedules from CRS. Then you have to parse the class schedules in order to get the schedules. So in this case, I searched for Mat 17, and I got all the classes available for the current SEM for Mat 17, and this is an example of a class. It's a TTH class 2:30 to 4 p.m. on MBAN 103. So this is just a sample data. So the next steps is to select which subjects to get. So one subject is Mat 17, then I can get all CS subjects. Then I will double check with the curriculum with which other triple E subjects to get, and then other GE subjects. Then my idea is to collate them and store them in a database so that they can be easily manipulated. So after you store them in a database, uh, there's some roadblocks I got when initially trying this method. Some classes locations are TBD, hence we can locate it in the map. So we just need to assume that TBD locations are conducted in that subject's home building. So I saw this with SURP. SURP's subjects are TBD, but you can assume that either most of them are conducted in the SURP building, but no planning subjects are requested in this subject area because this is more of a undergrad of computer science. So this is one of my roadblocks. Then next, another roadblock is that the classes are stored as strings. Hence, we need to still parse them to separate the daytime and location, etc. So it's not as simple as getting all the subjects, and you can easily separate the date and the time and the locations. You still have to parse them, and actually the locations are also encoded in some format that is not readily searchable in the internet. So that's one of my roadblock. So another next step is to store the GPS coordinates of the subject's location. So after I get all the list of the locations, I can find them and tag them to get the locations so that we can use tools to find paths between location. So an example is here, the math building. So this is the GPS location, 14.64 and 121.07. So we can use OpenStreetMap because OpenStreetMap is open, and then it has a good pathing for different buildings in the Philippines. It's good. There we can plan paths between locations here. Then another next step is to store the historical temperatures of the area and map them to the classes locations. But since we are only talking about Quezon City here, the weather information we get are usually by cities. So we just need to store historical data of date and time. So how hot is it during this block of time, and will it rain during the first semester or the second semester? Is it hotter? Is it raining? So is it feasible to still walk when it's very hot and you can bring an umbrella, or when it's raining? So that's another next step.
Franz, can you remind us
Yes, sir.
what is your goal and what is the strategy or change that you are going to make?
Sir, the goal is so my goal for the subject is to create well, software so that we can so that students can generate the best selection of subjects to take in a semester. That takes into account the distance between buildings, the time between classes, so that they don't need to sprint in between buildings, the time of day, so that is it feasible to walk when it's hot, and then one part of the study is to not use vehicles. So we focus here on walkability. So what's the best pathing, or what's the best schedule of subjects to get in a semester so that it's optimized.
So, will it be generic enough for example, next semester or next year students can also use?
Yes, sir. It should be generic enough.
Okay. Okay.
So that's it. So then that's the historical temperature. Then here's a sample historical weather data in Quezon City. We can see the lows and highs, and we can also see precipitation. When is it most likely to rain during class days? So that's it. So the next step is to determine determine how to rate sidewalk availability. So another wish list here is to rate how walkable is it to get in between locations. But I think since there's no data available yet, maybe I can add this if I have more time. So this just are there any roadblocks to get from point A to point B? Is there a sidewalk available like that? So I think that's a wish list for the study. So there, my next goals. I'm currently focused on the what do you call that? I'm currently focused on setting up the database because it's longer to set up. But once I have the database collected and the data are there and easily manipulated, it's easier to be processed and placed in simulations. So that's my progress. Thanks.
So my suggestion is to use the open source that is already available. So there is, I send here the links, what is called Open Tree Planner.
Okay.
Okay.
I'll check it, sir.
Right. So this is already used by many, including Sakai.com is actually using this. So otherwise, if you want to do it alone by yourself, I think that would be too big. So that is already available somewhere, but you just need to make it combine with your database a while ago.
Yes, sir.
Right.
Thank you.
Okay. Okay. So who's next? Is there any feedback to Franz? So if not, so who will present next? Anyone? Who did not present? Yeah, Jen. Jen Marie, go ahead.
I will present, sir.
Yes.
Actually, my group mates are not here,
Oh, who are we?
but this is not yet final, sir.
Okay, no problem.
And one of my group mates have decided to do this. It's just Yeah, so I did follow your instruction. There was part where to present optimized and
Oh, I think Nico dropped from this
this
class.
is online.
Yes.
Not good. So my group mates are Trisha and Nico. But one of my group mates is deciding to drop the course. So our study originally was the MAAS for the masses, but it was focused in Metro Manila. But since Metro Manila is very big, so we decided to get a smaller scale. That's the Bonifacio Global City. So we have changed our base scenario from the Metro Manila to BGC since BGC as of now is really among the major financial and commercial district, and it has become more congested. There's traffic congestion and the entry and exit points, limited public transport, and there's a lack of seamless integration with Metro Manila as a broader transit network. And of course, these inefficiencies have led to gaps in accessibility, longer travel times, constrained mobility of residents, workers, visitors. So are trying to implement the mobility as a service framework in BGC, hoping to enhance the transit accessibility. And as our alternative one, we actually tried to implement an IFN to optimize the multimodal transit routes, which we'll present later. And we are hoping that this integrates the BGC bus system to other forms of modal transports to make it a cohesive MAAS or mobility as a service platform. And
Can you define first what is MAAS, mobility as a service? Is this
actually it's actually just mobility as a service. So using different modes of transport by the commuters. So you use bus, the ride hailing, everything, and we are supposed to try to make it more seamless because in Manila, like there's the angkas, of course the private cars, the bus, and there's the private bus in BGC. So it's the public transport platform in different forms that we are trying to make their movement seamless so it helps in reducing the congestion and enhance commuter efficiency. Basically, that idea. And of course, among the structure one, this was originally presented before is regulatory frameworks for the global city. And these are the BGC bus service, the ride hailing, micro-mobility to minimize travel time and enhance urban mobility. And for our alternative to which is basically among the objectives is also to implement dedicated lanes, strategically located pick-up, drop-off points within the Bonifacio BGC to enhance transport network efficiency through IFN. So we are hoping that this can streamline mobility by identifying the pick-up and drop-off points. And among the structure will be targeting infrastructure improvements within the BGC, of course, with the help of the government. So initially, sir, we have actually identified the streets in BGC which are basically populated in terms of traffic congestion and long queues of public commuters. So we basically have identified this. The C5, Kalayaan flyover, of course, the EDSA, because it's really the 5th Avenue and 32nd Street, the Market, because it's commercial where all the commuters are going, the Bonifacio High Street, because it's the area for hangouts, and the 9th Avenue and High Street, the McKinley Exchange, Uptown Hall, and the BGC bus terminal, which is actually and we have made an IFN and overlaid our IFN over the BGC actual street network. And we tried also to compute for the capacity network and the premier network, the premier matrix. And for the implications, it has been identified that major roads such as the 5th Avenue and the 32nd and Bonifacio remain significant junctions distributing a flow in a balanced manner if properly and there's we need to do also a bottleneck reduction based on the limitations that we have made. So this is among the implications that we have to do based on the, and then we have to strengthen connectivity among the key nodes. So the major transit points such as the BGC bus terminal, the Uptown Mall, Market, we need to support accessibility and intermodal transport integration. And also, we need to reduce the redundant connections which should be removed, resulting in a linear network to avoid necessary infrastructure strain to make the efficient use of infra and its resources. Yeah.
I don't know.
We need to improve pedestrian and vehicular balance.
I'm not sure if your understanding of IFN is correct. So IFN is very big, okay? There is IFN for power dynamic, there is IFN for AI, there is IFN for transport, and so on. So I don't know which IFN you're talking about.
For this, we were referring to transport, actually, sir.
Okay.
Connectivity of streets.
So if you're
But
using
we have not yet come up with a clear conceptual framework and finalize the tools.
Okay. So I suggest we meet outside the class, probably in different session. Only your group. Is it okay?
Yes, sir. It's okay.
Yeah. So
it's very much okay.
It seems like you're still out of scope.
Yes, sir.
Right.
So we will just email you, sir.
Yeah. So let's make a schedule on that. Yeah.
Thank you, sir.
Thank you. Okay. Okay. Any other group you want to present? Yeah, it's good that you presented, so I can see that some problems, and then I can try to help you. Okay. So some group that need some more consultation, so we can have a separate schedule. Any other group? Pele, did you?
Not yet, sir. I probably would schedule a consultation and email you when that will be, sir, if okay.
Okay. How about John, Kenneth?
Thank you.
Yeah, thank you. Okay, so anyone want to present next? No? So let's break for 5 minutes. Is that okay? And then we come back. That is now is 8:53.
7:55.
Yeah, 7:55. So 8 o'clock. Is that okay? Then we can start with the lecture on MCDM. And thank you for all your presentation. Let's continue. Sharing. Hi. So I think you have learned this because you make the assignment. Okay. So I want to make it brief. Can you hear me?
Yes, Doc. Yes, Doc.
Okay. So what is this is starting to prioritize, say you have projects, okay, or you have tasks, okay, and then you want to prioritize your alternative, okay, a task, project, or scenario, okay. So based on multiple criteria, so we call this multiple criteria decision making or MCDM. Okay. The actual book of MCDM is very thick, like 500, 1,000 pages. So I just summarize all of this, okay? And I will focus on the main part. Okay? So I will show you especially about the transformation and normalization, and then also run reversal, okay, later on, okay? And these are the technique that usually we use for MCDM, okay? And of course, the best one is actually technique 4, okay? But along the way, we will say why this is actually the best one, okay? So by the end of this lesson, you should be able to make decision based on criteria, not just criterion, but criteria and alternative, okay? And you're supposed to say different technique of MCDM, multiple criteria decision making, and you're supposed to be able to quantify your subjective opinion for our decision making. So when we say decision making, okay, what is that? Decision making is a process, yeah, to choose alternative based on multiple criteria. Okay, so that means that's why a while ago when you presented only the criteria or the factors, okay, so I keep asking what are the alternative. Okay, so in any decision making you need to have this at least you have the problems, okay, you have the goal, and then to solve that problems, so you have the goal, okay, the purpose of decision making, and then you have several factors to consider, okay, with other criteria, and then you have alternative, that means the choice that you should decide. So if you don't have any choice, okay, so you keep saying, I don't have choice, this is my only way, then you don't need to make any decision because that's the only choice. So, okay. So, but in reality, you always have choice. Okay. The current scenario is the base scenario, okay, one of the alternative, and then you start to think of something else, which is probably not the same as today, or not the same as the current situation. Okay, something probably the reverse of that, or beyond of different alternative. It is not the same as the current situation. So then you will have at least two. Okay, one is called the base scenario, and the other one is actually something that is different from the base. And the base scenario is today or current situation, something that is different. Well, when you said there is no alternative, that's probably you will think that the other alternative is actually worse than today, but there is alternative. Okay, so this is what are examples, okay, of decision making. Okay, so you always have goal, okay, and then you have criteria and you have alternative. So for example, you want to decide the best office space, okay, and these are the criteria probably for area, yeah, closeness to customer, visibility, and so on. Okay, okay, and then the alternative are the name of available vacant space in the vicinity. Okay. Again, another example in decision making is to decide the best school. Okay, then you create different criteria. So probably based on distance, reputation, cost, okay, teacher kindliness, and so on. And the alternative are the name of the school under your vicinity, yeah, under your consideration. The same thing when you have goal to find the best apartment. So then you start to list down the criteria. Yeah, maybe the price, maybe the down payment, maybe the distance from your parent or the shop, or distance from the school. Okay, the neighborhood friendliness and so on. And then the alternative are the list of apartment under consideration. Is this clear or not? So when you want to make decision, okay, you need to have a goal. What is the goal? Okay, and then you need to list down the factors, the criteria, and then we list down the alternative. Okay. Similarly, if you want to select the best politician, these are your goal. So probably these are the criteria. So who decides the criteria? You. Okay. And who decides the alternative? Again, you. Okay. So you need to see the alternative, okay, which is based on the criteria that you have. Okay. So there is some connectivity between the criteria and the alternative. Okay. You don't make alternative that does not match with the criteria, of course. Okay. So say you want to determine that this is topic. Okay. So you can set any criteria that you want. Okay. For example, fast to finish, is cost, and so on. And then you list down, you brainstorm the thesis topic. Similarly, if you want to buy car, so you set the criteria of the price, the cost, maybe status, service, and comfort, and then the alternative are the one that you have based on the trademark or the type of the car. Okay. Similarly, if you want to decide just binary, whether to rent or to buy, okay, again, you create criteria on that. And then, of course, the alternative now become only two, yeah, to rent or to buy. If you want to do for improve the forest management, for example, then these are the alternatives, right? So these are the criteria, okay, that you can set. And usually in transport project, we always have what is called do nothing, or sometimes politically correct word is not do nothing, but do minimum, right? So do minimum is the same as do nothing. And then these are the alternative scenario. Okay. So remember, we have what is called MCDM, yeah, multi-criteria decision making. So this is only based on the alternative that you can think of, okay, with this feasible alternative at this point of time, okay, at this point of space. So, and usually you will list down criteria not more than 7. Yeah, this is based on Miller's law, right? That if you think more than 7, that is actually too much information. Okay, so for the first practice, okay, that's why I give you the assignment last week, is to set the problem that you want to decide. Okay, and then you state the goal of your decision and list down the criteria and alternative. Okay. Now, the criteria consists of two possibilities. Yeah. One is subjective values. The second is objective values. Okay. So when we say subjective values, that means you have opinion on the criteria and the alternative. So usually this is ordinal value. For example, preference, better satisfaction, important, and so on. So again, this have no right, no wrong. Okay, but the assumption is important here. Yeah, when you want to create subjective values, okay, the assumption are at least these three. Yeah, number one, it should be transitive. Yeah, when you say A is larger than B and B is larger than C. Yeah, when we say transitive, that means A is larger than C. So order matter. That means subjective values must be ordinal, not nominal value. Okay. Second, usually you have upper and lower bound values, which indicate the best to the worst. Okay. And then this is an important assumption. Yeah. The factors and the alternative must be independent. Okay. So if they are dependent, then you probably need to think of how to combine these factors together. Okay. Now, if you have attributes that can be measured objectively, okay, usually have units. For example, the cost, benefit, time, distance, speed, how often, frequency. Okay. These are objective values. Yeah. So then you can combine both subjective values and objective values together. Okay. So what is the problem with objective values? Okay. The problem with this is usually criteria will have different units. Okay. And because each value may have a different utility also. Yeah. So what's the problem if you have different unit? When your unit is actually larger or smaller, then the value change. For example, from meter to centimeter. Okay. So 1 meter is 100 centimeter, isn't it? So if you use centimeter rather than meter, suddenly the value changed 100 times. So become very big. Okay. So second problem is actually each value will have different utility. Okay. For example, increased floor area from 500 to 1,000 square meter may be attractive to decision maker, but the increase from 1,000 to 1,500 may be just marginal or less attractive. So maybe why? Because this change, attractiveness, is about relative value rather than the absolute value of 500 increase. Okay, so in that case, what is the solution? Okay, the solution number one is to normalize the value to 0 and 1 or between 0 to 100. Okay, so normalize the value so that when the criteria have different unit, you will still have the same range. Okay, and second, to have different utilities, then you transform those objective values into subjective utility values, again, in the same range of 0 to 100. Okay, then your question is, how are we going to transform? Okay, there are two ways, depending on whether the value is decreasing or increasing. Okay, so if it is cost, so cost, what is the characteristic of cost? The characteristic of cost is less is better. Distance is a cost. Okay? Time, distance, effort, cost. Okay? They are inverted. That means less is better. So in this case, the transformation must be using what is called this decreasing function. You can start to see decreasing function have certain value and then minus with certain values. Okay. So these are example of a transformation function that you can use. If it is a gain rather than cos, what is the characteristic of gain? Gain means the higher value is better. Okay, so if the function is actually higher is better, then you use any function with this increasing function. Okay, so then you can normalize. With this simple way of thinking of transformation, then you can go to what is called normalization. What is normalization? Okay, so normalization is process of transforming our index, okay, whether it is objective or subjective index, okay, into a certain range, okay. Usually the range is between 0 to 1 or 0 to 100, okay. So original value is d mean and d max, and then you make it into 0 to 1. Okay, let's make a notation that original value is d, okay, the normalized value is delta. Okay, so okay, or n in here. So original value is gain in here. Okay, if you have gain minimum and gain maximum, okay. So normalization is a transformation from the value of gain gi into 0 and 1. Okay. When the higher value is better, we call it gain. Okay. So this is the one of the simplest function that you can use, or you can use any other function. Okay. When your value actually lower value is better, so we call it cos. Okay. So in this case, the value is inverted. So you can start to see we have one value here minus the other value. Okay, so usually we have 1 minus, okay, this is the simplest function that you can use. Okay, so you can use this, but you can also use any function, not just this one. Okay, any function that you can use to normalize. Okay, so what is any function that I can use? Okay, based on the principles. Okay, normalization is basically an aggregation. So the trendy term is called data fusion. Okay, so you have sequence of numbers and then you aggregate. Okay, then you make them positive, and then you make them ratio. Okay, if you make them ratio, then the denominator must be bigger than the or equal than the nominator. Okay, and again, you can use any inequality to normalize the index that you have. Okay, I give you an example here. Okay, I can create a function like this. Yeah, this is in the website. Okay, so any function, yes, I can create any function like this. So this function, if we plot, you will have something like this. Okay, so depending on the value of a, depending on the value of a. So a must be positive. Then you can start to see any value of t initial value. Okay, for example, say negative 10 to positive 10. Okay, then it will normalize into 0 and 1. Can you see that? The delta here is 0 and 1. Okay, and the value of a here is just a different slope of this function. Okay, for example, when your value is -4 and a is 100, so when you input here, you will get the value between 0 and 1, which is 0.6. Okay, my point is you can use any normalization function. Okay, the easiest one is this one, but you can use any function as long as it is within this principle. Okay, so this is the usual way to do normalization. So this is for gain, right? When you use this is not linear function, not nonlinear. A while ago, I can use nonlinear function like this. I can also use this simple linear function. Yeah. Okay. Now, what happens if I put d minimum? I know this d minimum is 0. Okay. If I know d minimum is 0, then the formula becomes just this, right? Can you see? Okay. So in that case, I have simplified the normalization function. Okay. Again, I can also use other normalization function like this. So if I have the any value that I have, I can just divide by the sum of that. Yeah, this is what we will use later in the run. Okay, so this technique, you have any value and then you divide by the sum of that value. Again, you will have normalized between 0 and 1. Okay. Now, what happens if my value is having some negative value? In that case, you take the absolute value or quadratic. Okay. Yeah. So still have another function here. It's called the way to normalize. Okay. This is proposed by two persons, Bray and Curtis. Okay. So we call this normalization. Okay. If you have two values, okay, D1 and D2, how I will put them into -1 and +1 or between 0 and 1. Okay, so the technique is simple. If you have two values, okay, whatever value it is, real number, okay, and then you just minus one of them, say D1 and D2, so you minus, and then you take absolute value, and then at the denominator you sum. Okay, this formula will normalize any value of D1 and D2 into range of -1 to +1. Okay, example. So I have D1 is 5, D2 is 7. Okay, then you will have C between -1 to +1. Yeah. So now, if you have ordinal value, okay, usually you want to have ordinal value between -2 to +2, for example. Okay, how are we going to normalize this to become 0 and 1? Okay, the technique is again simple. Yeah, first you convert this to run. Yeah? Each of this value you convert this to run. For example, -2 is round 1. Okay, -1 is round 2, and so on until 5 here. Or you can reverse it, no problem. Okay, and then this run. Okay, I will use a small letter R here. Okay, and then the maximum of this run, okay, I will put as capital R here. Okay, so in this case 5. Yeah. Okay, and then we will use this formula to convert, yeah, this small r, okay, into delta, which is between 0 and 1. Okay, so for example, r, the small r here is 1. So 1 minus 1 is 0, isn't it? So for example, the r here is 5. So 5 minus 1 is 4. This one also 5 minus 1, again 4. So 4 divided by 4 is 1. See? So another example, the small r here is 3. So 3 minus 1 is 2, right? This one, the capital R here is 5. So 5 minus 1 is 4. So 2 over 4 become 1/2. Okay. So this is to convert the original index into normalized line like this. Okay, up to here, the normalization technique. Is this clear or not? Okay, so how do we know the normalization formula should we use? Pre-Curtis have denominator 1 plus 2. Okay, so the normalization method that you use, okay, is not the way I'm telling you is this. Okay, you can create your own normalization method. Okay, so if I want to free you from the technique that proposed by anybody, so that you can be creative creating your own technique, right? But at the same time, if you don't want that and you want the standard way, so just use this one. Wait. Yeah, use this technique. This is the linear one. Okay, so if you have a pair, then you use Curtis. Right. So if you want a linear model, use this one. If you want some non-linear model, you can create your own. Okay. These are example of non-linear model that I can use, or I can use exponential, for example. Any method you can use, or you can use this technique also. You can also use. Again, normalization method is up to you to decide which to use, as long as it is consistent. Is this clear or not? Yeah. Sometimes you get confused because there are so many methods. Okay, if you confuse, come back to just one method, this one only. This is for gain. Okay? Higher is better. So for cost, the same exact formula, you use 1 minus. Okay? This is exactly the same normalization method. Is this clear? Can we use different normalization? Yes, we can use different normalization scheme for different criteria, of course. Okay, no problem with that. Okay, good question. Okay. Next. Now, I will show you some magic of statistic. Is it okay? Let's
Yes.
do-
Let's go.
let's open. You can open your Excel. Let's do what is called statistical normalization, so that you will understand statistical normalization is not the normalization that I use here. Okay, I will open a new Excel. Okay, I will share my screen with you. Can you see the Excel already? Okay, let me make it larger. Okay, so let's create a random value. So I will put like this X. Okay, so let's create a random value, say random between, right? What number you want? 1 to 100? Okay. So let's make a data here. Okay, so this is our data. So that means every time I press calculate, it will have a new data value, right? Because random. Okay, so now if you want to put this, okay, into normalization, mathematical normalization, normalization. So then all you need to do is to get the minimum, okay, and the maximum, right? And of course, now you know the range. Yeah. Now, if you know the minimum and maximum of this data, which I do, which is 1 to 100, okay, I'll make it more complicated than that. Let's make it 112. So randomly, I just make it 1. Okay, so if I know this is 1 to 112, okay, what is the range? Range is maximum minus minimum, isn't it? Okay, then if you want to make it mathematical normalization, what you will do? Okay, now depends. Okay, this is gain or cost. Okay, suppose this is gain. Okay, so that means, okay, what I will have this one, yeah, minus with the minimum, right? And then I will open parenthesis, close parenthesis here, and then I will divide by the range. Is this clear or not? Okay. Then I will have the value between 0 and 1. Okay, so this one now the minimum, okay, 2, and the range 4. I need to put it into a $sign because I don't want that to change, right? Okay, then I will have the value is always between 0 and 1. This is the mathematical normalization. Is it clear or not? Okay, how about if it is cost? Okay, so if it is cost simple, okay, that means lower is better. In that case, 1 minus that normalization of the gain. Okay, as simple as that. That's it. Clear?
Yes,
Can
no.
you understand that formula now? Okay, so now I want to do what is called statistical normalization. Yeah,
Sir,
stat normalization.
can you show again the formula for the
Okay,
orange?
I will show, no problem. What is my slide? The formula, this one. Can you see? This is the value minus the minimum divided by the range. Range is maximum minus minimum, right? Okay. And then the normal, if this costs 1 minus that. Okay. You see, yeah? Clear, yeah?
Yes,
The
sir.
formula and the Excel match at this point. Okay. Now, I want to show you what is called statistical normalization. Yeah. So when we said statistical normalization, this is not between 0 and 1. Be careful. Okay. In fact, it will make between negative infinity to positive infinity. Okay. To create statistical normalization, you need what is called average. Okay, or mean. Yeah. Mean and standard deviation. Okay, so let's do that. Okay, so I have the mean, which is the average of the original data. Okay, and then standard deviation, I will have standard deviation of population, right? So there, I have the standard deviation of the population here. Okay, so the formula, okay, now I have statistical normalization. Usually we use Z. Okay, the formula is Z equal to X. Okay, minus mu. Okay, and then all of this divided by sigma. Yeah, what is that? The mu is the mean. Okay, the sigma is this one, the standard deviation. Okay, let us see what will happen if we do that. Okay, so I will have the X minus with the mean. Okay, this one I need to put parentheses first, and then I divide by the standard deviation. Okay, now you see this is larger than 1. Okay, and I want to put this, okay, these two no change. So in that case, I need to put $sign here. Okay, you start to see when we say statistical normalization, okay, what is this? When you have statistical normalization, okay, you will have negative and positive. In fact, the range now become from minimum of negative infinity to positive infinity. So what is that for? You will ask. What is this statistical normalization for? Okay, this is assuming that your value is normally distributed. Okay, this X. That means, what is the nice thing about this? Okay, look at this. Okay, the nice thing about this is the mean and the standard deviation now become 0 and 1. Okay, now look at this. I will get the average of this. Okay, of this Z is always 0. And look at the standard deviation of this. Yeah? Standard deviation of population of this one. Okay, is always 1. Yeah, this is practically 0. Okay, this one I will just put into numbers. 0. Okay, and now to prove that, okay, I will just keep making the change of random number here. And you see, even if I change the random number here, the magic of statistics tell okay, that the mean is always 0 and the standard deviation of this is always 1. Can you see that? This is what, see, the actual mean of the data keep changing, the standard deviation keep changing, okay? But when you normalize, okay, then the mean is 0 and the standard deviation of this normalization become 1. That is the meaning of statistical normalization. Okay, the range is between negative infinity to positive infinity. Normal distributed. Up to here, is there any question? Clear or not? Okay. Now let's go to the so normalization is clear, yeah. So now let's go to the MCDM technique. Okay. So let's go to the MCDM technique. So I will discuss here 4 techniques. Okay. Number 1, okay, this is something that you are not supposed to do this. Okay, the same thing with the rank and normalized factor, but the best one is actually the last one. Okay, let's go to the first one. Yeah, this is the simplest MCDM technique called cross tabulation MCDM. So you have attribute or factors in each row, and you have choices or alternative in each column. Look at this. We will use almost half of this course. We will use exactly similar pattern. Yeah, you will have alternative and factors. Okay. So and then you can create any subjective score. If it is objective score, you put it into subjective score. Okay. So and then you sum the score for all factor in its alternative, and then you normalize the score. Okay. I give you an example. Okay, say you have 3 alternative, choice X, choice Y, and choice Z. Okay, and these are the factors. Say, let's name it A, B, C, and they have different range. Can you see this? Okay, so factor A is 0 to 5, 1 to 100, so negative to positive, and 0 to 1. This is already normalized. Okay, when you sum all that, okay, you get these values. Okay, and then you normalize, and then you say it. Okay, based on this normalization, you will say, assume this is all K. Yeah, that means this is larger, right? So you will say Y is larger than Z, then larger than X. So you will choose Y in this case. But is it true? No. Why? The problem of this technique is because they have different range. Okay, and then you sum all of them together. So of course, in this case, dominant factor is only factor B, which is the larger range here. Can you see? Then the choice that you put is basically based on factor B, not the other factors. So this is bad way to do multi-criteria decision making, because practically you have only a few factors which have larger range. In fact, if you put this into meter, suddenly change also the value. So different unit have different values. Okay, so now what will happen? Okay, yeah, this is the problem. Yeah, the higher is better or smaller is better is not clear. Okay, inverted or not. Okay, now and then each factor will have different unit. If you change the unit, okay, you will have different score. And then each factor have different range, and each factor also supposed to have different weight. But you did not consider all of that, right? Okay, so then what is the possible solution? One possible solution is to normalize. Yeah, to normalize the score of each factor should be within the same range. Yeah, 0 and 1 or 0 to 100. Okay, and then you put certain weight for each factor. Okay, that's the way to do. Okay, and then you need to have consistency in the meaning. Yeah, whether it is gain or cost. Yeah, not both. Yeah, so the actual value should be gain. That means higher is better. If it is cost, then the value is inverted. So you need to put minus, 1 minus that value, normalized value. Okay, or another way is to put the rank rather than the subjective score. Okay, in that case, let's try first what will happen if we put the rank as the subjective score. Okay, so look at this score a while ago that I have here. Okay, now we can rank this, right? For each factor, we can rank, right? So you have 1, 4, and 5. What is the rank? So 1, 2, 3. Okay, so I put here. The score is 1, 2, 3 because larger is better in this case. Yeah. So if you use this kind of rank, so in each factor you will rank 1, 2, 3. Okay. And then if you use rank-based multi-criteria decision making, okay, and then you sum all of this, right? So, and then what will happen if you sum all of this? You will have normalized score, right? This is based on this. So how to compute the normalized score? Okay, from 11, 6, and 6, how do you get 26? You can use this formula. What is this formula about? How can I get this formula? This formula is actually come from, look at this, sum and divided by total sum. What is that? That is actually normalized. Come from this formula a while ago, this one. From this formula. Value divided by the sum of value. Can you see that? Okay, so, hey, this is value divided by the sum of value. Yes, I use that. So, but how can it has, the formula have 1 minus? Why it 1 minus? Because rank 1 is the best. So the value must be inverted. Rank represent a cost. Inverted. Right? Rank 1 is the best. So that's why 1 minus the normalized value. Okay? But next question, why it is half? You put it half because you have 3 choices here. Okay? So the actual formula, okay, is actually this one. Okay? So 1 divided by n minus 1. So n is the number of alternative. Okay? So if you have 4 alternative, you try. If you use rank base, okay, then 4 minus 1, so 1/3, not 1/2. Is it clear or not? You want to try so that you can understand this. Okay. Transform your subjective score into rank. Okay. So 1 is the best. Okay. Number of alternative, and then you compute the normalized score. Okay. What will be your preference decision alternative? So one problem with this rank is what is called rank reversal. Okay. So if you go to the model, I think there is a rank reversal there. Okay, or you can go to this also. So rank reversal. Okay. Say, can you see this paper? Okay. Suppose you have this kind of score. You have judges, 5 judges, and you have 10 items, and this other score. Okay. So each judge will put score say 1 to 100 to these items. Okay. And then what you will do is you because this is already normalized, so you just sum, right? You get the sum here, and say you get the average, and based on the average, now you rank them. Okay, so the largest average is rank 1. Okay, and then the second largest, okay, rank 2, and so on. Okay, so this is the usual score base. Yeah, so we in this technique, we have the score, we take the average, and then we rank based on that average. Technique 1. Okay. Now, what will happen if we don't do that? Okay. We rank first, and then we take the average, and then we rank. What will happen? Okay. So we have these values. Okay. 70, 60, and so on. For each judge, we'll do the rank. It just will do the run. Okay, and you see, it just will do the runs. Okay, once it just do the run, and then the same. We sum, and then we take the average, and then we run them. Okay, remember run is the minimum should be better, right? So in this case, again, we use the minimum. Okay, so what will happen? Let's compare the actual things. Yeah? Based on the score, this is the run. Based on the run of run, this is the value. So you will see the run is not the same. Okay? Some run is actually reverse. So this is the danger if you use run-based method. Okay? The run can be reversed based on the score. Okay? Some item will have reverse order. So this run-based technique always have some problem of run reversal. So, okay, then what should we do? Okay, the simple lesson use score aggregation, not run aggregation. Okay, because run aggregation may lead to run reversal. Clear? Okay, so with that, okay, let's come back to the slide. Okay. Another way to normalize the score, of course, you can put it linear like this. So this is another way to normalize. This is the one that I use, okay, in the next normalized vector. So each value will have different range, and then you normalize each factor. Okay, the way you normalize is up to you. So in this example, I use this value. Okay. So then what you will do? Normalize the score, because you already normalize the score and then you sum them, right? When you sum all of them, and then you get the run based on the normalized score. Okay, so then this is the result. Okay, so yes, ranking more reliable than subjective score? No, in fact, it's the other way around. Subjective score is better than ranking. Okay, so if you do ranking, okay, you will get run reversal. So better to use subjective scoring, and then you normalize. So important is to normalize your score. Okay, so the third technique using normalized factor, this is better than the ranking. Okay, this is already your practice last assignment. So then the best one is the last one, which is based on the weighted normalized score. So then you ask, how can I determine the weight? Okay, so determine the weight is actually subjective judgment, okay, based on the importance of each factor relative to the other factor. The way to do is actually pair comparison. Okay, so after you do any value there, and then you normalize the judgment, okay, based on division to the sum of judgment. I will give you example here. So say we set factor B and C is 2 times more important than factor D. Yeah, factor D is 1, then factor B and C is 2 times. So you set any value with this 2 in here. Yeah. Okay. So if this is 1, then this must be 2 times. If this is 2, this must be 4 and 4, right? So, and then say factor A comparison with factor B. So factor A is 3 times more important than factor B. See, pair comparison. So then B is already 2. What you will do? Multiply by 3. So you get 6. Clear? So then you get the sum, right? How to normalize? Easy. This value divided by the sum, that normalization. You see? The value divided by the sum is normalization. Based on which formula? This is the formula while I could have be used. This one. The value divided by the sum. Yeah. If this have contain negative value, then you can use this. Clear? So now we already get the weight, normalized weight, and you already have the normalized factors. Okay, then all you need to do is to compute, all of that. So before that, sometimes your number of comparison is too big. So in this case, try to reduce the number of comparison. So how to do? You sort the criteria from the order of the best to the worst. Okay, and then you put the best factor 100. Okay, and then compare the worst factor to the best factor. Okay, and then put them in terms of percentage, and then repeat again for the next factor and so on. So you always use pair comparison between factors so that you can start to judge. Okay, at the end, of course, you will do exactly like this. You normalize by the weight. Okay, so with that, okay, this is an example. So I have sorting the criteria, based on the order of importance. So this is the sorting of based on order of importance. So E is larger than C, larger than D, and so on. Yes. Good question. Is there any scenario MCDM technique 1? Technique 1 is bad. Don't use that. Okay? Unless it's already normalized. Okay. So technique 2 is based on ranking, right? So if the ranking do not have reversal, then the result is the same. So no problem, you can use. Okay, if there is a reversal in the ranking, don't use. Okay, now technique 3, which is based on normalized only, that means you assume the weight is equal. Right. So the best one is number 4, which is also based on the weight. Okay, this is now how to create the weight. Okay, so you have set this 100, say, and then you put the lowest, which is A. Okay, then A is, say, 40 of the E, the highest. Then from there, this must be higher than that, right? Based on this order, now you can set any values. Can you see that? Now this is how you create utilities, by comparing each of that. And then once you get all these values, you just define, so 100 divided by 350 is 29. So then you get the normalized weight. This is clear or not? Okay, so the last one is you actually normalize the judgment, okay, normalize the weight and normalize the score of each factor. Okay, with that, okay, this is already 0 and 1, each of this, okay, and then you also have the weight, okay, and then you just do some products, okay, then this is actually the best one. So up to here, is this clear or not? Okay. Normalization similar to Sati, okay. Them different. Now, Sati normalization use also sum. Okay, today maybe not enough time to discuss ASP, so maybe next week we will discuss ASP and Brown Gibson and IFN. Okay, so you can read the slide beforehand, okay, so that you can understand that ASP. Okay, ASP normalization, the one that you do, breathness, is actually just approximation. The actual ASP normalization is based on eigenvalues and eigenvector. Okay. So the one that you use is actually approximation of eigenvector. And that only happens if your number of factor or alternative is a few, okay? Maybe 3 or 4. Okay, so if you don't have any other method, okay, this is the simplest method, okay, to make prioritization. Okay, so you can use that. And after this, of course, you can do sensitivity analysis. Yeah, we can discuss sensitivity analysis next time. Okay. So these are the summary of what we discussed. Yeah. So number one, you need to identify the stakeholders, the decision maker. Okay, and then you identify the alternative. Okay, and criteria. Okay, and then for each attribute you assign certain values, and these values usually measure some performance of the alternative on that attribute. Okay, and then you decide the weight for each attribute, for each factor. Okay, and then for each alternative you take the weighted average. Okay, of course you need to normalize this. Okay, once you make that, you can make professional decision and perform sensitivity analysis. Sensitivity analysis means small change. What will happen if you create a small change in your scoring a while ago? Will the decision change a lot or not? Okay, so that's the meaning of sensitivity analysis. You want to create a small change in the score. For example, your score earlier was 7. Okay, if you change to 8 or you change to 6, will the entire decision alternative order change or not? Is the rank reversed or not? That's the usefulness of sensitivity analysis, so that you will know which factor or which alternative is actually sensitive to your score. Okay, up to here. Any question? Yeah, you did the assignment, so this week you don't have assignment. Yeah, but you can just read the 3 other technique of prioritization, which is AHP and Brown-Gibson, and IFN for prioritization. Okay, so that you will have more questions next week. Yeah. Okay, I think we have 3 minutes. So before any question, any feedback, what did you learn today?
Hello, Doc. Yeah. Hi, Doc. When we did the assignment, Doc, and I tried it to one of our, actually, in choosing the best contractor in our work. Yeah. I did it's like a tender process. You have to select most suitable contractor for your project, and then you set your criteria, and the alternatives are your contractors, right?
Right.
Then you can see you set your ranges, and then the most important thing is the weight of the criteria.
Yes.
It really affects if you change highest one, for example, your cost is 25%, and then the other one is 50% the time of completion of the project. If you interchange that, it will really affects the ranking or the final score of the alternatives.
Correct.
Yeah, it's very useful actually.
Right. What assignment is adjusted? Which assignment you are talking about?
The risk, sir.
Sir, I sent the screenshot.
Let me see. Okay, we will change that. Sorry. This
Thank
is
you, sir.
not even there. Okay. Thank you for putting this out. Okay. Yeah, the decision risk we did not even discuss, so of course need to move very far away. Yes, Gray, you want to say something?
Hi, sir. I'd just like to elaborate or ask further. Because in my assignment, I think I made more than 7 criteria. So, can you elaborate more why the
Search in
author?
Google. Search in Google. Okay.
Okay.
Miller's law.
Okay, I'll just look for it
I
myself.
will.
Thank you.
Miller's law. Right. Oh, why 7? Right.
Okay, thank you, sir.
Yeah, thank you. So the MCDM calculator in Revolut 2, okay, does not normalize yet. So you need to normalize the values if you want to use that. Okay. Okay, so thank you very much for today and see you next week. Yeah.
Okay, thank you, Doc.
Okay,
Good
bye-bye.
evening.
Thank you,
Thank you,
sir.
sir.
Thank you.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Thank you, sir.
Thank you.
Good night.
Thank you. Good night. And some of you want to discuss?